Yeah, hello viewers, welcome to the class for today. We are trying to model, we're studying into modeling real life graphs using inverse proportion. My student is in class. You can subscribe to this channel. Thank you. All right, can you hear me now?
Yeah, I can.
Okay, the topic model real life graphs using inverse proportion. And before we even move on, we should try to look at okay, we've done something on linear proportion, right?
Yes.
When we were looking at scenarios and we're like, is it a straight line graph? Is it this? So something is it's linear if, or we can say linear or direct if as one quantity increases, the other also increases,
Appreciate.
or as one decreases, the other also decreases. So, but if as one increases, the other decreases, then it's going to be inverse. And if as one decreases, the other increases, it's also going to be inverse. If we look at the increase and the increase, we can talk about the mileage and the fuel that the gas that a vehicle will use. If it's going to use 20 liters, maybe it could cover 20 kilometers. I'm just saying. So if I'm going to increase the kilometers to 80 kilometers, then I must increase the gasoline, right?
Yes.
So that means that is direct. But if we're talking about accomplishing a task or using up a kind of fabric to make maybe uniforms or something. So if we have a fabric that is like 10 yards, maybe we could manage it for two people, right?
Yes.
So if we cut it for two people, that's 10 yards. But if we have the same, maybe, and that means each one of them will be able to have five yards. But if we have the same 10 yards and we now increase the number of people that will use it to 10, then each person cannot have 5 yards. Each person will have
Five
what?
years.
2 yards. So that means the higher the number of people, the
The more
lesser, yeah,
you get.
the
Uh,
le-
oh
the
yeah, the
length
lesser
of,
you are.
yeah, yes. Okay, we're gonna continue shortly. Just hold on. So having said that, on to the next page. Just get rid of. Now this says everyone in a class is given 20 sweets. How many sweets are needed if there are 10 students? That means each person must have 20 sweets, right?
Yes.
So
I
if
see.
if we need if we have 10 students, that is 10 times 20, making 200 sweets. But if we have a class of 20 students, then we need 20 times 20, which
Mm.
is 400 sweets. If we have a class of 25 students, then we have to multiply also. And if we have a class of 30 students, then we have to say 20 times 30, which is 600 sweets, right?
Oh, wait, what? Everyone in the class is given 20 sweet.
Yeah. So you can see, right?
But surely for 10 students, there's like enough sweets for everyone. So wouldn't it be two?
Wait, wait. It
Oh,
said,
wait, no, two sweets. Oh, I was thinking like two sweets being given to everyone
no,
to share out that 20.
not really. What they're trying to say is that each person must have 20 sweets.
Oh, okay.
You understand?
Yes,
So
that
every
makes sense.
one person is given 20 sweets.
20,
So if we have 10 students, how many sweets do we need?
200,
200. Then if we have 20 students, we need 400. If we have,
400.
like that, like that. Now,
Yeah.
second scenario said 600 students, 600 suites are shared between a class. How many suites will each student get if there are 10 students?
So 60, because they're
60 for
shared
one,
between
yeah,
the
60
class.
for one. If there are 20 students, each will get 30 suites, right?
Yes.
Then if there are 25 students, So we just have to divide and say 600 divided by what? 25.
Mm.
So then we get the number of suite. And for the 30 student, we'll do the same thing. So
Yeah,
for the 600 divided by 25, we get 24 suites for one student. And the one of 30 students, each student will get 20 suites. And that is the D scenario up here. That for
yeah. So that's
20
the
suites,
inverse of that.
yes, yes, for 20 suites, 30 students, we need 600 suites. Now, what's the difference about your answers in question one and two? Well, in question one, we're actually finding the total number of suites, right?
Yes,
But in question two, we're finding the number of suites each
inverse.
student.
Yeah. So
Like the
yeah.
inverse, the questions are inverse. So, and that's why the
Yes.
answers are inverse too. Okay, now, let me see.
Sorry. So that must be an example of inverse proportion.
Yes, because if the first example is like direct, if each
Yes.
student must have 20, the more we increase the number of students, the more number of suites we need. But the second one, we have a total that is constant. We're not increasing the total. So if the students are 10, they get 60. If they are 20, they get lesser. If they are 25, they get even lesser. And if they are 30 students, they get lesser. So the more we increase the number of students, the lesser suites each student get. So that is inverse.
Proportion. Okay.
Yeah, inverse proportion. So you want to jot down something. The next page is just the answer. You can see for the first question, we have this, which are
Mhm.
the details for the first question direct. As the number of students increases, the answer also increased from 200 to 400 to 500 to 600, right?
Yes.
Okay. Then the second one, as we have a total in mind, which is 600, as we increase the number of students, the answer decreases, right?
Yeah.
So that is what we can say to that. So what is the difference being your answer? One, it's decreasing, and the other one is increasing. So the one that your answer is increasing as you're increasing the number of students, that is direct. The one that your answer is decreasing as you are decreasing the number of students. I mean, as you're increasing the number of students, the answer is decreasing in question two. So that is inverse.
Proportion. Okay. I
Yeah,
see.
inverse proportion. So now into the details of the class. It says a teacher has 2 hours to mark some books. Before we go further, let us just look into that particular statement. I want to mark some books and I have 2 hours, to mark the books. If maybe I cannot mark, more books within the hours. You understand me? Are you getting me? Oh, I'm not sure if the connection is intact there. Oh, I think we're going to just continue shortly. Can you hear me now? Okay. So, can you see the question?
Yep. I can.
A teacher has 2 hours to mark some books. Okay. He said, how many books can she mark if she spends 10 minutes on each book? So, we're just going to say how many 10 minutes can we see in 2 hours, right?
Yeah. 12.
Yeah, that's 12 because that's 120 minutes. So, that's 12. That means she can mark 12 books.
Oh, person.
Now,
Yeah.
Now, if we now increase the number of minutes she's going to spend on each book, that means she's going to mark lesser book, right?
Yeah. She'll mark fewer. She only gets to mark 6 books.
Yes. So, will she mark more or fewer books if she spends 20 minutes on each? So that will be fewer.
Well,
But if we reduce the time to
should
like,
only be.
yeah, if we reduce the time to like 5 minutes on one book, then she's going to mark more. So if you reduce the quantity and
Yes,
the other one increases, it's inverse. Or if you increase the quantity, like the time here, the number of books is going to be fewer. So that's also inverse.
yeah.
And that is the solution on the next page here. Do you need to jot down anything here? Not really, right?
Um, no,
Yeah, not really.
no.
Okay, so let's move on.
Thank you.
Yeah. So this one says 2 hours equal to 120 minutes. Okay. What would the graph of this relationship look like? Is the number of books marked in 2 hours directly proportional to the time spent on each book? Of course, it's going to be inversely proportional, not
Yes.
directly
Well,
proportional.
direct.
Yeah. So, and we
Yeah,
have
as
the,
one variable is increasing, the other is decreasing.
yeah, we have it here now. 2 hours number of books is wait a minute. Is it 2 hours or 2 minutes? If we change it to minutes, okay, 120 minutes. So if it's 2 minutes, that's 60 books. And if it's 20 minutes, that's 6 books. So what would the graph of this relationship look like? And is the number of books marked in 2 hours directly proportional? No, it's not direct. It's inversely proportional. And the graph is going to look something like this, okay?
Yes.
It's going to go downwards.
Even the
And
curve.
yeah, the points lie on the curve, not on the straight line. The graph does not go through the origin. The number of books marked is not directly proportional to the time spent on each book.
Okay.
Yeah, so, okay, time spent, okay, the number of books marked is still, the tree is still trying to, so it's inversely proportional. Okay, it's inversely proportional. So, let's see. Okay, it says I have a go at question 1 and 2 on the worksheet. Okay, let's go to the worksheet. Now you have the worksheet with you, right?
I don't have it in person, but
Okay. I mean that
yeah.
you want to attempt question 1 and 2.
Yes, I can do it. Yes.
Quickly attempt it so that we'll see. Yeah, I think you should be able to see it on the screen, but if I need to move up, you let me know. Okay.
Yes.
And once you are done, you let me know too. All right, viewers, we're
Okay.
going to continue shortly. Thanks for watching. You can subscribe to this channel. The first question says the time taken for 2 cleaners to clean a building is 6 hours. If there were more cleaners working, what would you, I mean, would you expect it to take more or less time to clean the building? So, what was your answer to that?
I said. Sorry. Did you get?
No problem.
Um, I said if there were more cleaners working, it
Mhm.
would take less time to clean the building. As the more the people, the less time for everything to be cleaned.
Yes, that's correct. So, I said, why would you expect this?
Sorry.
Yeah,
Yes.
the second part says, why would you expect this?
The more the people, the less time for everything to be cleaned.
Yeah, we will say, okay, yeah, that's correct. That's correct because we can assume that they're working at the same rate.
Ah, I see.
Because if they're not working at the same rate, if they work less, then we cannot judge the time. So how long will it take? Would it take one cleaner to clean the same building?
12 hours.
12 hours. That's 2 times 6. Because two people use 6, then if one people goes away, so that means one person will use firstly use 6 hours, and that's half of the job done. Then another six
Yeah.
hours. How long would
Yeah.
it take 4 cleaners to clean the same building?
Right. I said 3 hours initially, but then I went for 1.5 after that.
Wait, the 1.5 should be for the D option, for the question D.
Yeah.
While
Yeah.
the 3 hours is
Three.
correct for the option C because you can say um, a person has 12 hours in all. So if they are now four, they can share 3 hours duty.
Hmm.
Then how long will it take eight cleaners? That is 1.5 hours because you just divide
Yeah.
12 by 8. So what assumptions have you made in your answers to part B, C, and D? Yeah, we assume that they're
Um,
working at the same rate. That's just the assumption. You understand?
yeah, I do.
So the next one says we should complete the table. So what were your numbers on the table? What are your numbers?
Sorry, I'm just like refining it because I know that I got some wrong.
Okay. Let's see.
The next one, I wasn't quite sure with it, so I just left it out.
Okay. What about the next one?
So the one after that, three.
Three. Okay. The next one.
I wasn't quite sure with that one either, so I left it
Okay. What about the
blank.
last one?
Well, 1.5.
Yeah, that's correct. So the one you left out, the three, just divide 12 by three. So that'll be four, right?
Oh, yeah, I see.
Then you divide the 12 by the four, that'll be three. You
So
divide the 12 by the six, that'll be two.
two, I see.
Yeah. So the last
Makes
one
makes
says, yeah, the last one says, why is there not a column for zero cleaners? Because the job will not be done, and it will take
Yeah,
forever. It will take forever time
yeah.
to get the
Zero
job done.
cleans has no column, as nothing will be cleaned,
Yeah.
meaning there's no hours for cleaning taken.
So it will take forever job.
Yeah.
It takes four builders 24 days to build a hotel. Wow. Assuming that all the builders work at the same rate, then we have to complete the table. So we have only the four portion there, which is 24.
Yeah.
So what's your first number for one builder?
96.
96, right?
Yes.
Yeah, that makes sense. Because if you say 24, yeah, that'll be 24 times 4, okay? Because
Yes.
it's the 24 hours for each person. So multiply by. What about the two builders?
48.
48. That's 96 divided by 2. What about the three builders?
36.
Is it 36 or 32? 96 divided by 3.
Yes.
Uh,
32.
32. So what about the six builders?
Now I see what I need to do.
Okay.
434. Please just redo that one, please. Sorry.
Okay, you want to redo that aspect. All right. No
Yes.
problem. One, the
Yeah.
first, for one builder, we have, that's question two. For one builder, we have 96 days. Two builders, we have 48 days. Three builders, 32 days. Six builders, 16 days. And eight builders, we have how many days again?
12 days.
12 days. Draw a graph. You drew your graph, right?
Yeah.
Did it go downward or upward? From left
It
to
went
right?
downwards as a curve.
As a curve from left to right. That's correct. So you just plot the points. Use a graph to estimate how long it would take 10 builders to build a tower. What did you get for that?
Well, I kind of said 9.6 days, but
Yeah, 9.6 days. That's correct. You can easily divide 96 by 10. Is it
yes.
possible to work out the y-intercept of this graph?
Um, I said no. It's not possible to find the y-intercept of this line, as it lies on a curve and it's not a straight line. And
Is
it's not
not a,
straight either.
is not straight. What does y-intercept actually mean in the real sense? In the real
The
essence?
point where the y-axis meets the x-axis.
So that means if the point that your line or your graph cuts the y-axis, right? The point where
Yeah.
your line cuts it. So what happens at the point where a straight line that we are plotting, let's assume it's a straight line, cuts the y-axis. That means at 0 days, number of days is on the horizontal, right?
I
So
see.
at 0 days, are we expected? Wait a minute. At zero number of builders, rather, number of builders are the horizontal. Number of days is at the vertical. So at zero number of
Yeah.
builders, what happens to the number of days? The days is going to go forever. So it cannot intercept the y-axis.
I
If
see.
it should intercept, that means we are saying, oh, if we have zero workers, the building is going to be built in a certain number of days. That is at the y-axis.
Okay.
But that will never happen. So that's why it will never intercept the y-axis. You were right by saying it is impossible. You understand? But the
But my reading wasn't correct.
yes, but the reason. So the reason is that at zero number of builders, the number of days is infinity, so it can never be on the axis. What is it possible to work out the gradient of this graph? Explain. Mm. So what did you put for that one?
Right. Uh,
Okay.
yes, it is possible to find the gradient of this line. As we just have to select 2 points which lie on the curve.
Mm, that's true. That's true. So you select the point and try to we're trying to find the constant rate. Like
Yes. Yes.
that's true. Okay, and that comes to the end of that one. I think we still have time to go back
The
to the lesson. Four workshops can produce 1,000 parts in 12 hours. What other values can you find? What assumptions are you making? Then we have a table. Okay. Four workshops, 1,000 parts in 12 hours.
uh,
We can talk about one workshop. How long is it going to
yeah,
take one
producing.
workshop?
Yeah.
So if four use 12 hours, if four of them they use 12 hours, so that means each workshop has used 12 hours. If only one
Yeah.
workshop would do it, that would be 12 in four places.
Mhm.
And
So
that
that'll
would be
be
48.
3 hours.
That would be
Oh,
48
48
hours.
hours.
Yeah, 48 hours. 12 in four places because one workshop has used 12, I mean 12 hours. So the four of them use 12 hours. That is 12, 12, 12 hours of work for the four workshops. So if
So
only
if
one
48.
workshop want to be saddled with the responsibility,
Oh, yeah. Okay. No.
then it's going to
Yeah.
have to complete 4 rounds of 12 hours.
Mhm.
That'll be 48 hours for the first
Yeah.
one. Then you divide by two, you get 24 hours. You get 12 hours. You get 6 hours. You get 4 hours, and you get 2 hours for 20 workshops.
Mm.
So that is what we can weigh. I think the yeah. Okay. It said, is the time taken directly proportional or inversely proportional to the number of workshops producing the parts? Yeah, it's inversely proportional because as the workshop increases, the time reduces to even 2 hours from 48
Yes.
hours. So the more workshops are open, the quicker the parts will be produced. That's true. If the people in the workshops are working at the same rate, then the relationship will be an inverse proportion relationship. Okay. Now, looking at this one, okay, they're trying to find what are those values that we already have found. Wait a minute. Did I say 2 hours for 20 workshops? Let's check it again. 6 hours. Oh, sorry, six, not four for the 16. That would be 3 hours,
Oh,
right?
yes.
No. Yeah, that'll be 3 hours for the 16, right? Can you hear me? Oh, I think there's a kind of disconnection there.
Yeah. Yeah.
Okay. I said something at the top there, which is incorrect. Okay.
Uh,
I assumed,
is the yeah, the 8 and 16.
yeah, 8 and 16. 16 would be 3 hours because you divide 6
Yeah.
by 2 from the 8. Then I assumed that 16 was doubled for the next column, but it wasn't doubled. Okay. That's 20, not 32.
Okay.
If it were to be 32, we just get 1.5 for the bottom, right?
Mhm. Yes.
So, but now we have to like check that it's 2.4, not 1.5. It will still take more time because we did not talk about 32 workshops being opened, okay?
Mhm.
It's just
Yes.
20. So from 3 down to, so that means we can actually start from the first one. One workshop is how many hours? We said 48, right?
Yeah.
Then three workshops will be 16 because we divide 48 by 3. And 20 workshops will be 2.4 hours because we simply divide 48 by 20, okay?
Yeah.
What did you say?
I was I, I was gonna say it's like how do we like find out the relationship which we use to work out
Work out the
the other
values, the
values in
time
the time
taking.
taking column?
Good. From the one we were given from this
Yeah.
particular spot, we knew that 4 companies or
Yeah.
4 workshops, they're using 12 hours. All of them together used 12 hours, right?
Yeah.
Mind you,
Yes. 40.
if
Well.
if the 4 workshops, that means a workshop used 12 hours. The other workshop also used 12 hours. The third
Yes.
workshop also used 12 hours. And the fourth workshop also used 12, but they
Ah.
used the same 12 hours at the same time simultaneously.
Uh, because they're working at the same rate.
Yeah, and at the same time too. That's why we say 4 of them, they used 12 hours. So if only
Hours.
one workshop want to do it, workshop A will spend that 12 hours and workshop B, C, and D are not
Ah.
working.
So it'll be that those 12 hours
Mhm.
in four
In
places,
four
assuming
places.
they're working at the same rate.
Yes.
I see.
So that is how we got 48 for the first one. You understand?
Yeah, I
And
do.
if the workshops are 2, just divide 48 by 2. That'll be 24. If the workshops are 4, divide 48 by 4. That'll be 12. The workshops
Mm.
are 8, divide 48 by 8. That'll be 6, right?
Yes.
And if the workshop has 16, divide 48 by 16, you get 3. So for 20, divide 48 by 20, you get your 2.4.
I see.
You understand?
Yeah,
Okay.
I do.
So now you can see all of the values are being filled here. He said, why is there no value for 0 workshop? He said the parts would never
That
be
will never be
produced.
produced.
So it's a forever time for parts not to be produced. And this is the graph for that one. It's also not going to have a y-intercept. No. Graph of inverse proportional relationship with curves. The curves will never touch the axis. Then the axes are called asymptotes of the curve. Okay.
Acid. That's a new word.
That's a new word. Yeah. You need to take note of it because you are going higher now. You understand?
Yeah, I do.
So he said the axes are called asymptotes of the curve. So let's see. To the question, it says it takes 2 employees 6 hours to stack the shelves in a supermarket. Ron has drawn the graph to show the relationship between the number of employees and the time taken to stack the shelves. Okay. Write one thing that Ron has done right, and write one thing that Ron has done wrong. Were you able to write what he has done right?
I said that he's plotted 2 points correctly from his table of values.
Okay. So the 2 points now, let's see, for two workers, that's 6 hours, right?
Yes.
Okay. For one worker, should have been 12 hours, yes or no?
Yes.
But did is line or curve? It's not a curve, it's a line. So did the curve shows 12 hours?
No.
Then number two is that the curve is showing 0 hours. I mean zero worker. That at zero worker is going to be 9 hours. Would the job ever be done? No. So what he has done wrong is that he did not make it a curve.
I see.
You
Yeah,
understand?
I'm thinking that.
He said,
I was thinking that he did make it curve, but I
yeah,
wasn't sure.
yeah, he didn't make it a curve. And you can see that the line has an intercept on y. And what's the meaning of that intercept? That he is saying at zero employee, the job will be done in nine because it intercepts at nine, right?
Uh,
So, and the job would never be done. So it shouldn't have, the line should not have met the y intercept. Though the 2 points are okay, but for one worker, should have gone like a curve to pass 12. So you can see it on the right side here. It's more like
yes.
something like the graph here, but it's not the same graph. So, um, so you can continue now, right? Or do we just continue looking at it?
I think that can go on. Oh,
Okay,
thank you.
okay.
Uh, so he has also said that
Uh,
at